I'm Robin, and this is BitBirdie, where I'll be giving you an update on my Godot Engine game. It's a bullet hell game with combat similar to Enter the Gungeon, but it'll also have an overarching story and interesting conversations with NPCs like in Night in the Woods. This past week, I've been working on the first enemy in my game. I call it the sapling. Let's see him in action. So you can see him here following me around. When he gets close enough, he'll start his attack animation and shoot leaves at me. And then after he's done, he has a little recover animation, and he'll start following me around again. Alright, let's see how this guy's implemented. So we're in the sapling scene, and we have the animation tree selected. The tree root is an animation node state machine, and we have 3 states in here: run, attack, and recover. There will be another death state coming probably in the next devlog. So let's go into run here to see what this looks like. Here we have 2 nodes. Let's select here. We have the run up animation and the run down animation. With this, we can change the blend position. So when it's below 0, or actually when it's below 0.01, negative 0.01, it'll play the run up animation. When it's above 0.01, it'll play the run down animation. So it would be nice if it was 0 and 0, but placing these both at the 0 line won't work. I also thought that maybe placing them at the edges here would work, but that will actually result in playing one animation and then only playing the other when it reaches the point exactly. Yeah, I just undid that change. Let's look at the code for movement. So we're in the sapling script now. The first thing that we do is set isMoving to true so that it'll start following the player. Just ignore this leaf stuff until we talk about attacking. Let's just minimize this. So basically, every frame, if the player exists, then move if isMoving is true. So what move does is it gets our state machine and puts the state into run if it isn't already. This run state right here. Then we get the direction to the player, and we use that direction's Y to set the blend position that we saw before. Then to actually move the enemy, we need to get the 8 directional direction and use that to set the velocity. You might have noticed that the movement isn't actually fluid. It's stopping and starting depending on where he is in the animation. How I did that was in the animation player, for run down and run up animations, I have it calling the stop moving function at this part of the animation where he sort of bends down as he lands. And then I have him start moving again shortly before this frame where he jumps. I initially had it at like this, where he would stop moving and then start moving right as he jumped, but that actually looked pretty stilted. Having it like this made it look a bit more natural somehow. Going back to the animation tree, if we play the attack animation, you'll notice that on the last frame, all his leaves disappear. This is because I need to replace them with actual leaf objects to shoot at the player that aren't, part of the sprite sheet. So going back to the code, if we expand this now, we'll be able to see all the attack code. So if we aren't attacking and we're close enough to the player, set attacking to true and stop moving. And then we set the attack and recover blend positions to the same one that run is in. This is so that the sapling won't change the direction it's facing while it's attacking or recovering. And depending on the way the sapling is facing, we might have to flip the leaves. So what does that mean? Right now the leaves are in the right position for the attack down animation, but if we had the attack up animation, they're no longer in the right positions. We would then have to change this to -1 to get them in the right positions for that. Once the sapling plays the last frame of the attack animation, the start attack function will be called. Let's just minimize this move code because it doesn't matter anymore. So this function will be called. So what leaves is an array with each of these leaf scenes in it. If any of the leaves are still out there in the world shooting around, recycle them and then spawn them. If we go into the leaf script here, we'll see that recycle sort of resets it and sets its position back to where it started, and spawn just makes it visible. And then we shuffle the leaves array. The reason I did this is so that each time the sapling attacked, the leaves wouldn't go out in the same order. It's pretty subtle, but I thought it might look a little bit more natural, and it was pretty easy to implement. It then starts these two timers, the leaf shoot timer and the attack duration timer. The attack duration timer determines how long the whole attack lasts. So once that time's out, we'll call finish attack and it'll enter the recover state. Right here. What the leaf shoot timer does is every time it times out, it'll shoot a leaf. In the shoot leaf function, it'll get the leaf from the array and call attack on it. So if we go to the leaf script, attack will set is attacking to true, and it'll also set the attack direction to the player. And then every frame, it will just head towards the player and also rotate depending on the rotation speed. And then if the leaf index is less than the amount of leaves in the array, then we just start the shoot timer again. So when we go into the recover state, it'll play the animation. And at the end of the animation, it'll call start moving, which is that function that we saw before. Right over here. So let's take another look now that we know how it's implemented. Its direction changes based on where it is relative to the player, and that's done using the blend position. The leaves rotate and also go into the direction of the player. The recovery animation plays. Sorry, didn't get such a good look there, so we'll do that again. Recovery animation plays and it goes back into the move state, or the run state rather. Or if I'm still close enough to it, it'll go right back to the attack state. Hope you guys enjoyed devlog number 6. If you guys want to see the previous devlog, you click that thing. If you guys want to see the first 4, they're on my blog up here. You can also follow me on Twitter somewhere up there. And of course, if you want to see more devlogs, make sure to subscribe and maybe give this video a like if you're feeling generous today. See you next time.